You're rolling.
Fantastic. Fantastic. It's good for you all to join us here today. So we're going to talk a little bit about critical infrastructure protection in the U.S., specifically beyond kind of the reference to code, which I will get to. This is really a plea for your interest and participation in the conversation when it comes to national critical infrastructure protection. I think we have a lot of a variety of people working in the space and contributing their thoughts. I think the basic security and hacker community actually is significantly underrepresented. So I just put this together in the past half an hour, so it's a little incoherent occasionally. Please bear with me, I'll do my best. So who here actually, when I say the word critical infrastructure protection, what do I mean?
Power plants, transportation,
Okay. Any other?
Treatment, anything we need to keep the lights on, the food coming.
What would be involved typically in critical infrastructure protection? What would it, like we're doing it, what would it be? Because there's kind of an action word in that sentence.
You need both physical and network security. You got to keep the supply chain running, keep the power plants getting whatever fuel they need, keep people from not stealing copper off the lines because they need money, and keep the people from foreign countries not to flip on your generator out of phase with the grid instead of flying in.
Yeah, that's usually bad. You're right. We'd like to keep people from doing that. So what critical infrastructure protection ends up being when it's done on kind of a national scale is the word protection is wrong. What we're actually looking for is assurance. And so it's a meta conversation about we want to feel comfortable that for what we're willing to spend, stuff isn't going to blow up. And so when we talk about assurance, there's a lot of different pieces to that aren't necessarily technical, and that kind of the hacker and the security crowd aren't normally involved in. So unfortunately, when we don't have assurance, what we do is we get into the protection business. So what happens if I'm in a country and I have a national interest, my citizens have a national interest in making sure things don't blow up, and I don't feel kind of warm and fuzzy that everything's okay, I'm going to go in and either force somebody to do it or do it myself. And so when we're talking about security, we're talking about hacking and vulnerabilities. Having a large government with lots of money that we don't necessarily trust for a lot of very obvious reasons come in and try and poke at that level of detail isn't necessarily a really good idea. I know I'm not comfortable with it from a cultural standpoint, from a civil liberties standpoint, but also from a pure systems engineering standpoint. That's dumb. It's not a good way of doing it. It's micromanaging in the worst kind of way. And so there needs to be a more rational approach. We need to find a way to actually create some level of assurance. Recently this year, you've probably seen the news, the White House came out with an executive order for the government to go do better critical infrastructure protection. Part of that is they told the National Institute of Standards and Technology to go forth, get input from the country, and build a national cybersecurity framework. Unfortunately, nobody really knows what that means, even including the people who are running it. The implications of that framework would be the purpose of that would be to have national goals that says, we really don't want stuff blowing up in this way. What are we all doing about it? From a hacker standpoint, this is important because we talk about vulnerabilities all the time. We talk about ways people can break things. And we keep throwing them up kind of into the ether and hoping that the world will get better somehow. There is no good framework for keeping that going.
How's that working out?
Right. And so, having done this for a few years, one of the things I'm advocating is kind of not to borrow a term, but a BSides version of the framework that NIST is actually developing. There's no reason that we can't there's no reason that it takes 400 people at 4 different conferences, that are, instead of smart modeling and hacker and thinking people, they're asset owners and operators and industry association leaders and company VPs. And so what we're trying to work on is actually create a rational framework for national cybersecurity that makes sense and that it's supported by people who are actually thinking through the problem instead of, it's a good analogy, basically they're asking the customers of the car to design the car for them. It's not their expertise. They might know, if I'm an electric plant utility owner, I kind of know what I want to make sure it doesn't happen, and so I have investment in what the requirements are. But I should be the one that is being asked on how to build the car, and that's what we're doing. So, from getting into a little more specific level, one of the ways I started looking at what a national framework might look like is to actually extend the protocol stacks that you guys are all very, very familiar with all the way up to a national level. So start treating the process a little bit more like object-oriented programming. And I've been told a few times, and a few times just today, not to get into how to slice the sausage, but what the results would look like. But I think the only way I can start at this point without the background is to talk about how to make it. So one of the problems we have when we're talking at national level is errors get blown up, right? It's if you jack up the amp on a bad speaker, it's going to sound noisy, it's going to sound terrible. And so seemingly simple activities like figuring out what's important to us, figuring out what to do about it, figuring out how to arrange resources, figuring out how to identify what the appropriate vulnerabilities are, they break down at scale. And so one of the things protocol stacks get us really, really well is define interfaces. It gets us very discrete areas that don't have to care about anything that anybody else is doing. And so the framework that we're working on actually starts creating protocol areas that says, we're gonna get this information from this area. We don't care how you got it. We're going to do our piece of the cybersecurity thing. We're going to define whatever we need to, and we're going to pass it up or sideways. We're going to publish it to whoever we want it. Basically, we're going to try and take a model view controller approach to it. The importance of the model view controller approach in a national framework is when you have this many people talking about what cybersecurity is, how many answers do you think I would get? I'm not going to go through the exercise, but if I asked you all what cybersecurity is, probably more than there are people in the room. And that's kind of a truism, right, at this point. So imagine you're talking about something that involves hundreds of thousands or millions of people. You can't really have a productive dialogue about that. So we're looking at basically giving kind of an executive layer piece of the protocol stack, a testable version of that looks at what potential threats are in a business environment, a kind of a resource management piece of the protocol layer, and tying it all the way back down and actually treating it like a computer program. Some of the people have come up to me and said, well, if you treat it like a computer program, people are fuzzy and they're not as detailed as kind of binary bits and bytes. And that's true on one hand, but we're not actually, go back to assurance versus protection. We're not protecting against a vulnerability today. I don't care if somebody can blow up a specific power plant today. Security for me, from a large scale perspective, is a long-term trending problem of quality. We want to make sure that, for the most part, few enough mistakes are made along the line that we can actually manage it, that we have a way to resolve issues. And so, when you start looking at it, it becomes much more of a fuzzy problem where if I reduce my error rate by 50%, I've actually made substantial progress. My risk from somebody breaking into my stuff has actually gone down without having to run into fidelity problems associated with managing each individual action by an individual person at an individual time, or each individual vulnerability. So aside from the programming standpoint, the other interesting trick that we're trying to introduce into the framework is the idea of authorized user actions and authorized roles as vulnerabilities when you're talking about cybersecurity management. In other words, the theory is that you have a security state at a given moment of time. That's not necessarily a technology problem. The technology is an outcome. It's a result of people doing things that they were authorized to do. Whether it's my vendor, lied to me, whether it's they didn't implement the right requirements in software, whether it was bad coding, whether it was my boss, didn't really prioritize my security stuff, whether it's my, whatever it is, your security state is basically an aggregate of decisions that people have made. And so when we start hacking at this a little bit, instead of talking about, hey, let's go and attack every single vulnerability that comes up, let's actually start looking at the root cause of where this starts. And so we want to start with what are the possible things people can do in a legitimate capacity. It's a very, very large list, but it's a finite list. It's not emergently complex. It's limited. And so if you can start to define the major places that errors get introduced, you can actually start to build interesting threat trees and interesting models around a range of resources. It sounds fuzzy and it sounds policy stuff, and it is. But the basic idea behind doing it this way is that it segments the problems into areas that we can solve discretely. They don't have dependencies on each other. And that as, if we swapped out every bit of technology we have today with pigeons, so if we start communicating with IP over pigeon, it would still work. We wouldn't have to change the strategy. We wouldn't actually have to change the policy. We could just get different people involved who understood how pigeons work a little bit better than they understood how Ethernet worked. And that might seem like a kind of an extreme example, but it's not, because that's how you get in good programming. That's how you get resilience. That's how you get long-lasting things. That's how you keep people out of your hair, is you have discrete approaches. And so one of the limitations to the way, and again, I'm still advocating you guys participate in this as much as possible. One of the limitations to the way the federal government handles this right now is there are, again, asset owners, there's academia, there's security vendors, usually at a VP level. There are a bunch of different people participating. There's no mechanism. So if we could open source the process and create a competing version, not to supplant theirs necessarily, but my real goal out of this is to, beyond introducing good ideas, to actually get the smart people involved who might have been actually disenfranchised in the overall process. I don't know if I said this out loud a minute ago, but I've been talking about this for years, but most of you guys have never met me. Because the people who are doing this don't, at an operator level, at an individual person level, they might show up at DEF CON. But the ones who are making decisions, the ones who are building the framework, aren't security people per se. So, and there's, when I did slightly different, more technical things, I couldn't get involved in this conversation because my boss somewhere, they were senior enough, they were the ones who were to speak for the company. There was no real, and that's never a good thing, really, especially at that level. So, coming forward the next few weeks, we'll put out some details about how you can get involved in the process. I would really appreciate any insights. I'm going to use the last 5 minutes for questions or feedback, please. And to actually get to the code, one of the neat outcomes of this, in my mind, and it's maybe not the most valuable outcome, is that when we talk about large-scale policy, usually we have to wait 5 years or 6 years or 10 years or 2 years. We've invested a lot of time and effort into running through it and see if it works. If you actually take a model view controller approach and kind of build classes, you can actually instantiate objects. You can actually potentially verify the at least sanity of a policy framework in terms of a computer program. So one of the goals out of this, at least from just to satisfy my own interest, if nothing else, is to actually be able to say, here are the different pieces, here's the inputs we might want to put in it, and boom, we actually get an answer, and we can see how the result for the security state changes over time. Long term, if we're talking, I don't know, singularity type science fiction stuff, we're, in my opinion, running into emergent complexity problem. Things are not linked as strongly as they should, or as resilient as the different efforts aren't linked as resiliently as they should. So when we start building policy level code, that starts to be able to link very, very cleanly eventually into technical code. Stop disambiguating, to use those. No, disambiguating. Now I've confused myself trying to make a joke. Don't distinguish between human and computer systems. They're basically the same thing. People do things, they arrange things for some sort of outcome. A computer is just a proxy. So include them in the protocol stack, and please consider contributing. Questions, thoughts, feedback?
Do you have it's hard for you to show, obviously, because you don't have slides, but I know, kind of what is your model like?
So it starts with 4 components. It starts with 4 components. The top layer is basically your strategy management, which gets into what's my context for security, what do I actually want to, what do I want to have happen? When we talk large-scale national security, very often we don't bother to explain when we're done what we want to accomplish. We just say we're going to be more secure, and so it doesn't end. More importantly, we don't fail. We keep doing the same stuff despite the fact that stuff keeps breaking, because we don't have actually a good definition of success. So we can't just undeniably say that didn't work, instead of, hey, let's buy more IDS and see more firewalls. So there's a layer that's top to bottom, and the bottom layer is more, the middle layer ends up being linking, which is what are my resources, how do I manage them, what are my capabilities to actually achieve these goals. And then the bottom layer ends up being what are the architectures, what are the different pieces, that are going to link into my technical protocol stacks. From left to right, what's interesting is we're doing on the right-hand side, we're doing basically, these are the things we want to enable, these are the things we want to defend. So you take a defender standpoint. I want to make sure that my company continues to make money. I want to make sure that my reputation is managed. And then we're taking a left-hand perspective, making that testable scenarios. Because you can actually say, I want to defend this, and never have any idea if you're actually being successful. Conversely, if you can actually go through a process of developing threat scenarios, you can actually make sure there aren't not only the things that you want to accomplish you're accomplishing, but also define things that you might have missed or connections you might have missed. So take a testing side, from a threat perspective, a defense side, and then top level is context, and bottom level is kind of the technical, and there's a linking layer between them. And then it feeds out to basically whatever your technical implementation is at the bottom. You can stack them because and that's the model of the MVC. There's no there's no views and controllers. One of the values of having a model first is we can actually go through to different subject matter experts. We can go talk to risk managers, executives, hackers, and go from a controller standpoint and from a view standpoint what actually belongs in this place now that we've segmented everything appropriately.
You're going to open source a solution and present it to the government?
We're going to present, it's open to who we're going to present and how we're going to do it. I come from an open source development background, so that's certainly an option. The government in this case has actually been really, really, really good about taking feedback. It's one of the only times they ever have, especially in cybersecurity. But the problem is the feedback they're getting isn't.
What feedback have they taken in the past?
In this particular process, all of it. They're basically managing in this case. So what they're doing is they're holding a series of workshops, and they've had 3 so far. They have 400 people from all over industry, all over the US show up and say, this is what we think a framework should be. But almost nobody here is there.
The first one is all video archive, and unfortunately they're getting the guy from Visa saying, you should copy PCI because it works so good on credit cards. It's going to protect you life and death situations. And they're hearing from like senior people in Symantec. They're not really hearing from.
This is where the problem is, right?
So this is basically grassroots saying, here's an alternative proposal. If you vet what you've done against what we've done, it may reveal opportunities for compromise.
You gotta have a lobby too?
That's what my talk is.
Yeah, I would, and if you're interested in the larger scale of the world, I think even larger than this is going to see Josh's talk.
Yeah. Because without lobbyists.
We need an integrated campaign. We're going to stop throwing stuff over the transom and figure out what results do we want, how do we navigate the influence chain, and flank them.
How receptive were they to PCI recommendation? Just out of curiosity.
Do you know?
They don't want to, because of the way a public-private partnership works, it's all voluntary. So this framework, I'll give you a more in-depth answer offline, but basically, they don't want to upset the cart as much as they can. So if there's existing regimes and somebody says it's working, they're going to let it go.
I'm just trying to connect the dots as to why a credit card processor would in any way impact SIP. It's not.
They said
right.
It's got international acceptance.
It's international acceptance because the banks say you have to use it.
Right. And SIP, they're trying to stick with 2 within that scope. So to my point, we don't have a model. So it's good. So you didn't even mean to, and you're already touching on the kind of the spaghetti code that this really is. And so I think we can do a better job of structuring it for them, and actually get better answers. That said, I can't repeat enough that when people provide input as best they can, they assimilate the 400 or 500 or 700 different pieces of input they get at a given juncture. So anyway, thank you. Appreciate you guys listening.